Okay, so for chapter 4, um, we're looking at indifference curves and how those influence consumer choices. So in our first question here, we're largely asked a definitional theoretical question. Um, and this is referring to this idea um, can we have a backward bending indifference curve? And um, in essence, we can't. If we had two goods here, goods X and Y, and the indifference curve were backward bending, meaning it looks something like this, then you would have a situation where you could have, sorry, you could have a situation where the consumer would be indifferent to having this bundle versus this bundle, despite having more of X, which, sorry, I hate it when it does that. I have to zoom out here. Let's try it again. You could have a situation again where you could have the same amount of Y but more X, which in this case would imply that Y doesn't contribute anything, but X does. But what we know from the rest of the curve is that Y must have been contributing something when, or in this case, even here, it would be impossible to have a backward bending supply curve because the only way you could have the same amount of Y but more X and be indifferent would be if Y didn't, sorry, in this case, sorry, X, sorry. X would have to be contributing nothing because you have more of X but the same amount of Y. But if I were to go, so that would be, let's say, between bundles A and B. If I were to go from D to C, I would have more X, less Y, and still be indifferent. So there'd be now an inconsistency. What is it? Is X contributing something or is it not contributing something? Between D and C, we're implying that X is contributing something because I have less of Y and more of X and I'm still indifferent. Okay, in number 2, we have chocolate cookies and chocolate candy. Chocolate cookies are, it's a good, meaning it contributes something positively. Chocolate candy is neutral, meaning it provides nothing. So how would that look? So if candy is on our y-axis and cookies are on our x-axis, and cookies are the neutral good, again, sort of like how we have up here, what that implies is that a person would be the same amount of happiness having few cookies versus a lot of cookies. So we could call that indifference curve 1. If they now had more candy, they would now be happier. So in essence, when the good on the y-axis is a good and the good on the x-axis is a neutral good, the person will be happier as you move higher up these indifference curves. Okay. Okay, so now we're asked to provide some analysis here. What we know already from the completeness assumption of indifference curves is that every bundle does have some relationship between the two. So what would happen if the person said that they preferred B to F? So they prefer B to F. What would be the problem? Well, the problem in this case would be is that, well, we should add this here. And this is important. And I'm not sure why the book didn't say it. Assuming that both of these goods are good goods, meaning that they're both positively contributing, you could not prefer B to F because of in essence, that more is always preferred to less. You always want more. And F has more books than B. Presuming that everything is good goods. Now we're told that they prefer bundle E to bundle B, but cannot tell you what the relationship is between C and E. Well, dude, we've got a problem there then. If you can't tell me what's going on between C and E, now we've got a completeness problem, which is what I started out my discussion with for this. So completeness would say that every bundle has to have a relationship with each other. Consumer reports that they prefer bundle B to C, prefers bundle E to B, but prefers bundle C to E. Well, now we would have a problem with the logic of this, right? So if they're preferring B to C and they prefer E to B, then that would imply that E is better than B, which is also better than C. But here we're saying we prefer C to E, which can't be true. So this would be that our preferences are not logical. In other words, that this is having to do with transitivity. Okay, then in number 4, we have 5 different combinations of movies and books. And then we have combination A representing 2 movies, 3 books, C, more books and same number of movies, B, E, and F are other combinations. So what do we know after we add this indifference curve? So what would we say about combination B? Okay, so first, compared to combination E, B would be providing less satisfaction because presumably E would be on a higher indifference curve. So higher indifference curves are more preferred. When we compare it to combination E to C, same thing. C would be providing less. And then finally, when we're comparing A, when we're comparing it with A, C would be providing more, right? Because presumably A would be a lower indifference curve. Okay, I'll pause here for a second. Okay, let's look at number 5. So here we have our minimum level of consumption, and we're given parameters where we're told that given parameters be able to draw the indifference curves. And what we have to do is create a situation where you'd be shading in, where you'd be creating the indifference curves in terms of what's preferred to not preferred. Now, if we were told that if we were told here we've got indifference curve 0, which is implied here, indifference curve 5 here, indifference curve 6 right here, the question is what would be the problem with indifference curve 0? Well, the problem that we have here, which is implied by this equation here, sorry, I'm just going to try and change it this way. If we're told that x plus z is less than or equal to 4, that gives us this entire triangle here as the actual indifference curve. Well, the problem with that indifference curve is that you're implying that something that's in the interior here is the same as something there. Now, what we know is that from these two bundles right here, that one would prefer this bundle, which has more of both goods, to this one, which has less of both goods. But because they're on the same indifference curve, you're saying that they're also equal amount of happiness. So our problem here is that indifference curve 0, because it's so thick, it's violating more is better, where you could be on extreme parts of that indifference curve and be at a point where non-satiation or more is better is violated. Okay. Okay. Now this one, one second. Okay, so this one's going to involve a bit more math here. So let's start. Okay, so here's our function. And we're asked first for what's the marginal utility of B. Well, the marginal utility of B oh, sorry. Okay, sorry. I'm going to change this only because when I printed things out, it was algorithmic. So forgive me. I already wrote it out here with Z, so I'm going to do it with Z, if that's okay. So MUZ, so now again, I would use the exponent rule here. So I would have beta AB alpha Z beta minus 1. And then for that's just using the exponent rule. You know, and I'll say this too, if it gives you problems like typing this in, and I could totally see where you could have it correct, but you know, the keyboard shortcuts or whatever aren't making it easy. I could totally see that. Don't worry. I mean, when it comes to the problem set and the exam, you get the handwrite out thing, so you're not going to be affected. Now, for the marginal rate of substitution, the marginal rate of substitution is going to be the negative of MUB over MUZ. Which is now going to essentially be Let me make sure here that, yes, we're good here. Okay, so that's going to be wait, mine is different here. Sorry, I'm going to pause 1 second just so I can confirm what the problem is. No, actually, sorry, we are one error to fix here. In terms of the setup. So going back to this is where we're running into problems. Just to stay consistent here, so Z is on our horizontal axis. So remember, when this is set up, the way we typically see this is X, Y. So in essence, our Z is forming the role of our Y variable. B is forming the essence of our X variable, which then in essence gives us at the marginal utility of the two, which we know the MUZ already because that's actually right here. So it'd be beta AB alpha Z beta minus 1. Now the marginal utility of B would be now the alpha going out in front. Alpha A B alpha minus 1 using the exponents rule. Z beta. And now what we need to do is simplify this. So we have, well, first we know regardless, our beta and alpha are going to be in our answer because there's going to be no crossing outs here. But you'll notice here that the A's cross out. In terms of the B, we've got a beta to the alpha in the numerator and a beta to the alpha minus 1 in the denominator. That leaves me with a B term here because I've got an alpha in the numerator and alpha minus 1 in the denominator. And the Z's, I've got a Z to the beta minus 1, a Z to the beta. That's going to leave me with a Z in the denominator. So simplifying everything, I have beta to the B over alpha to, beta B over alpha Z. And of course, we should have added this here. It's all negative because it's a MRS. Number 7, we've got a utility function, which is essentially MB to the 1/2 power, or square root of MB. And we're told here for the values, we've got T at 1520, V at 2020. So then we can solve this here. Twenty times 20, which is square root of 400, which is essentially 20. And then 15 times 20, which is going to equal square root of 300, which is going to equal 17.32. And the utility at point V is going to be our answer here. That was 20. And moving from T to V, how much does our utility increase by? Well, it increases by this difference between the two, going from 17 going from 17 to 32 to 20 is a difference of 2.67, but here's where they totally are tricking you. That's the total difference from the two. But they want the marginal utility, so that would be per unit, whereas this is 5. So now we need to take that 2.67 and divide by 5 to get approximately 5.535 or 0.54 because they want you to round to 2 decimals. Okay, 20 minutes. I'm trying to make these rather short, and this is becoming rather long. Number 8. So here what we're looking at are the food stamp program and the federal housing program. And we're told that people become eligible for both, and presumably that there'd be some problem because the money isn't interchangeable. So here we're told that she gets $500 a month as income. So obviously she can spend that on whatever she wants. Then she gets $100 in food stamps, $150 in a housing subsidy. So what would that budget line look like? Well, in terms of the one, right? Presume that's a straight line. If she just had income, she'd have a one-to-one trade-off between the two, right? Because she could choose to do whatever she wants with her money. Now, if in addition to that, now she's in addition to this income, she's now given food stamps and a housing subsidy. So now it would start here. And then reflecting the food stamps, she gets, what is it, 100? Yeah, 100. And then, so that's 100 in food stamps. So no matter what, she has to spend 100 in food stamps. Then it's going down, same slope at 1-to-1. And then, what is she given here? $150 in a, so that would be 600. $600 to $150. All right, so what happens is that now with her additional foods, so with food stamps, it'd go from 5 to 600, but she has to spend at least 150 on food, or sorry, on housing. And then over here, what you see is that she has the $150 food allowance, or housing allowance, and she has to spend at least $100 in food. So I'll repeat that again because that was a little confusing there. So she has $500 in income, right, that she just gets from working a presumably incredibly shitty job. So she has $500 a month in income, and she gets $100 in food stamps. So now the budget constraint starts at the $600 point on the x-axis where food is. Now, at that point, if she spends for housing, she gets a $150 voucher. So that's why this now is vertical up to 150. Then we've got our 1-to-1 slope, And then it stops here at 100, which is where the food stamps would start. And you'll notice that the y-intercept here is 150 higher because that's the amount of the housing allowance. Okay. Now, here we have a utility function, 100b square root of c. And we're given bundles A and E. Mine was a little different here. Let me see here, 9 and 16. Okay, sorry, I have to adjust this again because I solved mine not doing this here. So I'm just going to change this here slightly, and then I'll recalculate. 1 second. Okay, I'm just going to stick with what mine has here. So A is 8. B and 49C. And my E is 7B and 4C. Well, then all we really need to do here is substitute that into the equation. Right, so this is just plug and chug. Right, putting my 8. So for A, I would just put in 8 and 49. And then for E, well, let's just do it. So that would be 5,600. And for E, that would be 100 times 7 times 4. Well, square root of 4. Which is 2, obviously. And it gets me 1,400. And so which bundle would he prefer? He would prefer bundle A, obviously, because it's got higher utility. And his total level of utility would then be the 5,600. Okay. Okay, now try to go a little faster here. Hopefully it doesn't reduce our level of understanding here. In number 10, we've got a specific tax of $1 per gallon of gasoline. And we're looking for what effect that has on our budget constraint. So presumably, what that would do for us then is that if the gasoline is measured as gallons per week, and it's a specific tax per gallon, it's going to pivot with now the x-intercept being closer to the origin after the tax is imposed. On number 11, we have here a single bundle of 4 books and 4 DVDs. Price of one book is $33.75 and one DVD is $33.75, then what's the consumer's level of monthly income? Well, in this case, it would be our, sorry, I'm going to make my life easy. I'm not going to, if you're watching this so far, you can be sympathetic, and your numbers are going to be different too, so. Okay, so what I did here is I just changed it to what I had that I solved for. So I had a notion here where I had 4 and 4.75. So obviously now it's going to change this point here, but you get it. And I'm given the price of a book and the price of a DVD. So that would mean that I then need to calculate this and multiply the number of books by 4 and the number of DVDs by 4.75. Oh, sorry. sorry. My DVDs were 60 actually. So it'd just be 60 times 4.75. 4.5. My number of DVDs here. So 67.5 times 4 would be 270. And then 60 times 4.5 is also going to give me 270. 270 plus 270 is going to be 560. That's my total. So essentially what you do for number 11 is you multiply your bundles by the prices of the two goods and then add those two together. Okay. Number 12. It's largely a matter of logic here. Only in the interest of time, given that we're at about the 33-minute mark. And I can pretty much assure you, you're not going to see this on the problem set or the exam. I'm going to skip it here just to save time. But in this case, you would need to write out the trade-offs for each of these to be able to graph out what the trade-off is between sports and academic performance. So sorry, I'm just going to skip it in the interest of time here. In number 13, we are, let's solve this one out here. Okay. Go to utility function, 2st, marginal utilities. These should be pretty self-apparent. MUS would be 2T, MUT would be 2S. Cost $50 for a new pair of shoes or to go out dancing, and they have $600 to spend. So, what is the marginal rate of substitution? Dude, you don't even need to do any math because it would just be, well, I guess you do need to do some math, but it'd be pretty. 2S over 2T negative, which would just be negative s over t, which means it's just a 1-to-1 ratio. Because in this case, if she has $600 to spend and each one costs $50, and she has to do, and each of them are essential, then essentially you've got the person essentially could spend up to 12, could buy up to 12 pairs of shoes or go out dancing 12 times, presumably in bare feet. But it's a 1-to-1 ratio. So it'd just be 1. And when you graph this out, you'd be at 12 and 12. Okay, Diego's got a utility function. This one takes a bit of time to solve out, but I have a suspicion it's among the more difficult here, so let's do it. Okay, just making sure. Okay, so there's some differences in the prices, so I'm just going to change that before we start. My PX is 5. And my income was 1,000. And we essentially have to find the optimal bundle. So what do we need to do here? We're going to need to set the MRS equal to the price ratio. So let's start with the price ratio first, since that should be pretty easy. That's just going to be PX over PZ. Which is essentially 5 over 2. Negative, obviously. And now we need to find the MRS. So our MUX here is, I'm wondering if it's easier. Sorry, it's just really tough to, I'm going to try something here. Sorry, I just want to draw, and I want to draw a lot faster than it's letting me. Okay, let's see if this is faster. Oh, beautiful. There we go. That was PZ equals 2, 5 over 2, PX over PZ. Okay, so here's my price ratio. Now we're going to do MUX over MUZ for our MRS, and so that's going to equal now our MUX. I'm now going to do the exponent rule, so that's going to be 60x, right? Because I'm going to do 100 times 0.6, and that's 60. 60x to the negative 0.4, z to the 0.4, right? Just keeping that over. So now doing this, right? So it's going to be 40, because the 4 goes out in front here. 4 x to the 0.6, z to the negative 0.6. 60 over 40 is 3 over 2. And essentially we would have z 0.4 over z negative 0.6 would leave me with a z in the numerator. And x to the negative 0.4, x to the 0.6 is going to leave me with an x in the denominator. So 3z over 2x. Now, why am I setting up that MRS there? Because the problem would be is if I set up this MRS and I said equal to this price ratio, the problem I would still have is that I have two unknowns. So I can't really do very much until we do the substitution into the budget constraint. So in essence, I'm going to do xpx plus zpz equals 1,000. Which would be x times 5 plus z times 2 equals 1,000. But what we also now know is that if we start to set up this 3z over 2x equals 5 over 2 negative negative, then 6z equals 10x, and then z would equal 5/3 x. Now, the beauty of that is look what I'm going to do. I'm going to put it in right here. So now I'm going to have 5x plus 2 times 5/3. This is a 2, remember, not a z. So now I would have 5x plus 10 over 3x equals 1,000. And if we work here with our common denominator, that would give us 15 over 3x plus 10 over 3x equals 1,000, which would essentially be 25 over x over 3 equals 1,000. Multiply each side by 3. So now 25x equals 3,000. X equals 120. And then, once we know what x is equal to, z equals 5 over 3 times 120. So 3/4. 5 times 40 is 200. And there we go. Okay. 15 is largely definitional. Again, I really want to keep this short here. But what would we say about that utility maximizing point? We would say that that point here is the utility maximizing point is where the MRS is equal to the MRT. So in this case, it's going to be our point B. And then if the price of books falls, sorry, I suppose if the price of books falls, it's going to change our slope of our budget constraint. And so if the price of books is falling, it's going to pivot outwards like that. Okay, I'm just going to keep going here. 16, looking at the endowment effect with a kinked indifference curve. And so what we would generally see here is that there'd be a higher value on the good if they own it. than if they're considering buying it. And this again is only because we're dealing with the endowment effect here. I know some of these descriptions here are pretty bad, but I'm trying to keep this short. Bounded rationality and the endowment effect, these are definitional. So I'm just going to leave you with those. And in number 19 here, Max, a German, and Bob Iyenk are avid readers with identical income and tastes. And then we're looking at a situation where they have where the where they're taxed, but the tax on ebooks is less than the tax on printed books. For Germany and the United States, but the after-tax price of ebooks would then be higher for printed books in Germany only. So what that does is it alters now our budget constraint again. Now we're not told whether this is a specific tax or a unit tax. So we don't really have any idea there. We're making use of this idea of what would we know for certain with these taxes being imposed. The only thing that we really know with any certainty is that for Max, the German, he's going to buy fewer ebooks and more printed books than Bob because of those after-tax prices, presuming that the books are the same and that their trade-offs between the two goods stays constant. And at least in this case, it should become evident once you start to graph these out, which obviously we can't do here. Okay, sorry, I know these descriptions are getting a little short here, and so they might be a bit incomplete. You know what, for 20 and 21, you're largely graphing these out anyway, so I'm going to let you all deal with 20 and 21. But if you do have a question about 20 and 21, just email me and I can make another video for that.